Okay. Let's see if we got any good jokes today. Have I told you guys any geometry jokes? Like zero? Like not even what did the acorn say when he grew up? Gee, I'm a tree. Get it? Okay. What does what do you call a mermaid's undergarments? A mermaid's undergarments. It's a little risque. Algebra. Get it? Well, jokes are one of my most favorite things to do. I oftentimes get so stressed out because I'm always like, we got to cover all this stuff that I don't take 2 minutes to say the funny jokes. My book's special because it has some extra ones in it. Yours doesn't. So I'm going to tell you a couple jokes today, and they won't be amazing. They will never get any better. They will always be very lame, but they are fun math jokes. So let's see. Since I haven't told you any. Okay. What do you call people who are in favor of tractors? Protractors. Yes. Um, see if there's another one. Well, okay. Nope. What keeps a square from moving? Square roots. All right, the Spanish, this is just kind of a little humor, not really necessarily a joke, I guess. The Spanish teacher says to the student, why didn't you translate the verb? And the student says, I did. I moved it 3 inches right and 2 inches down. There you go. All right, let's see if there's any good ones for chapter 2, since that's what we've started. It's done. All right, you ready? Last one for today. How is a geometry classroom like the United Nations? How is a geometry classroom like the United Nations? Let's hope. That's good. So they both have an objective? They say they both have lots of rulers. All right, and I told you they won't get any better. All right, so last week we talked about 4 kinds of statements: a conditional, a converse, an inverse, and a contrapositive, right? Okay, and what does the converse do again? Very good. Switches the hypothesis and the conclusion. If Q, then P. All right? What does the inverse do?
If not Q, then, or if not P, then Q.
Very good. So it negates the original statement. If not P, then not Q. What does the contrapositive do? Okay, it does both. It switches and negates. So if not Q, then not P. Today we're going to learn a 5th kind of statement, which is what section 2.4 is all about. And it's really pretty much the whole section's about this one extra statement. And then 2.3, we're going to learn 2 laws, the law of detachment and the law of syllogism. And really, it's not huge that you know the difference between the two. I'm not necessarily going to say, is this the law of detachment or is this the law of syllogism? But you have to be able to use them. Okay, so you're going to have to make some conclusions. You're going to have to decide, did they use it correctly? And so we're going to get right into that. But before we do, we talked last class period about inductive reasoning. Inductive was based on patterns. We had to look and see what was happening to determine what happens next. And I went ahead and had you last class period add deductive reasoning to your notes. But this is where the book actually includes it in 2.3. It's the process of reasoning based on facts, definitions, theorems, postulates, properties. So the first part of your notes is going to give you 2 different situations. One here on the front, and if you flip your notes over, there's one on the back. Your goal, you and your partner need to decide, are they using inductive reasoning to make their conclusion or deductive reasoning? So are they using facts or are they using a pattern of events? Okay, so go ahead, I'll give you a minute. You guys decide, the one on the front and the one on the back. Deductive is facts, inductive is patterns. Inductive is based on a pattern. You have to observe something happening over and over again. Yep. So you're trying to decide, did the person make their decision on the myth being false based on a series of facts that are given or on a series of events that have occurred over and over and they had to watch a pattern? Okay? Once you're done, flip it back to the front and we're going to check the first one together. Okay, so we're going to start here. There's a myth that you can balance an egg on its end only on the spring equinox. That's the myth. The person concludes the myth is false based on this information in the middle, that a person was able to bounce the egg on July the 8th, September the 21st, and December 19th. Did they make their decision based on patterns or based on facts? Did they have to watch a series of things occur over and over to decide, or was there a given set of rules listed? Patterns, so this should be inductive. This is inductive. They had to see what happened each time. The person bounced the egg this date, they bounced the egg this date, they bounced the egg this date. That's a pattern. They watched to see what happened. Okay? Next one. There's a myth that the Great Wall of China is the only man-made object visible from the moon. This person says this myth cannot be true based on this bit of information in the middle. The Great Wall is barely visible in photographs taken from 180 miles above the Earth, and the moon is about 237,000 miles from the Earth. Is that a pattern of events, or is that specific facts? Facts. So this is deductive. Okay, so pretty much the rest of the school year, we will be thinking deductively. We will be given facts, theorems, postulates, properties, definitions, and we'll be making decisions based on those things. So we won't be watching to see what happens each time to determine what we do. Okay? All right. First law today is the law of detachment. The law of detachment says if P implies Q is a true statement. So if they give you an if-then statement, and it is true, and then you find out that P actually happens, so your hypothesis occurs that it's true, then you can conclude that Q is true. Okay, so if you make a 74% on the test, then you made a C. If that's a true statement, and then we take our test over chapter 2, and I pass back your test, and you find out you made a 74%, what can you conclude? That you made a C. That's the law of detachment. Okay? Be careful. If I pass back your test and it just says C at the top, can you conclude that you made a 74? No. So the law of detachment does not go backwards. Q does not imply P. You can't go backwards. Just because Q happens does not guarantee P will happen. If P happens, Q will happen, as long as that was a true statement that it started out as, if then. Okay? So they're going to give you a series of examples here where they're going to ask you, did they use the law of detachment correctly? You're going to say yes, valid, or no, invalid. If they went forward, they did it validly. If they tried to go backwards, it's invalid. So for example, determine if the conjecture is valid by the law of detachment. Given, all of this is given to you. This is the conclusion or the conjecture. So if the side lengths of a triangle are 5, 12, and 13, then the area of the triangle is 30 centimeters squared. That right there is your if-then statement. P implies Q. You are given that that is true, okay? You're also given that the area of triangle PQR is 30 centimeters. So what I usually do is start and ask myself, what's my hypothesis P? What's my conclusion Q? So what's the hypothesis? Okay, so that's our P. What's our conclusion? Okay, the area of the triangle is 30 centimeters squared. That's our Q. Are they giving us that P happened or that Q happened when they tell us this information right here? They're giving us Q, right? They're saying the area is 30 centimeters squared, which is the end of our sentence. They're trying to say that if the area is 30 centimeters squared, they can conclude that triangle PQR has sides 5, 12, and 13. Are they going forward? P implies Q. Or are they trying to go backwards? Q implies P. They're trying to go backwards. They're saying this is Q, and if Q happens, then P happens. And you can't go backwards. So is this a valid use of the law of detachment? No, this is invalid. Think about it. What this is saying is if a triangle has an area of 30 centimeters squared, that the sides have to be 5, 12, and 13. Can you think of a triangle that could have a different base other than 5, 12, or 13 and still have an area of 30? What could be the base and what could be the height? Okay, so I could have a base of, careful, that would give me only 15 for my area. So how about, okay, so if this were 10 and my height were 6, that would give me an area of 30 because it's 1/2 base times height, which is not a side length of 5, 12, or 13, right? Okay, and even not even thinking about it mathematically, the law of detachment says if P happens, Q happens. They told us Q happened and tried to go backwards and say that P would happen. You can't go backwards. Is that making sense? Okay, let's try another one. You and your partner decide if this was a valid use or an invalid use. Okay, what do we think? Valid or invalid? Valid. It is valid. Again, if you need to, identify your P and your Q. This is talking about teams winning 4 games. That's our P. Conclusion is they win the series. That's Q. They say the Red Sox won 4 games. That would be that gave us P happened. They concluded they must have won the series. That means they're concluding Q. right? So if P implies Q, P did happen, so therefore Q would happen. Valid. Questions? The key is just you can't go backwards. Your Q cannot imply P, okay? Just because the conclusion happens, just because you made a C, does not mean you get a 74. Making a 74 implies you get a C. So whatever your if-then statement is, you can't go backwards. Any questions on the law of detachment? Are we really good? All right, so now we're going to look at the law of syllogism. Are you good, Andrew? Okay, let me know if you're really not in a minute. Law of syllogism, okay? The law of syllogism is similar to the law of detachment, but the difference is you're going to have two if-then statements. Two of them. So if P implies Q is true, and Q implies R is true. So every time they're going to give you two if-then sentences. Notice what they have in common, though. When you look at that, what's the same in each sentence? Q. So the conclusion of one of the sentences will be exactly the same as the hypothesis of the other one. So for example, if you made a 74% on the test, then you made a C. If you made a C, then you passed the test. Two if-then statements, right? The part that they had in common, making a C, right? So what the law of syllogism says, if there's a part that's in common that's exactly the same, you can get rid of that part and write a third if-then statement. P implies R. Take the hypothesis from the first part, and it implies the conclusion from the last part. So if you made a 74 on the test, then you passed the test. And you can get rid of the part about making a C. Does that make sense? Okay. Again, you cannot go backwards. If you pass the test, does that mean you made a 74? No. So R does not imply P. You can't go backwards. So again, you're going to look at a series of events and you're going to decide, did they use the law of syllogism correctly or did they try to go backwards? So first example here. Given, if a figure is a kite, then it is a quadrilateral. If a figure is a quadrilateral, then it is a polygon. Okay, stop right there. Let's go ahead and make our new statement. What's the part they have in common? The quadrilateral. So what I usually do is just get rid of that. Then it is a quadrilateral if it is a quadrilateral. Mark all that out. Now what is your new if-then statement? Perfect. Is that what they said for their conclusion? So did they use it correctly? So this is valid. Does that make sense? Law of syllogism? Okay. Look at the next one. Decide if that is valid or invalid with your partner. Marking it out. Yeah, I think that helps me. Once you have an answer for this one, go ahead and try the next one right beside it. So finish this page of your notes. Valid or invalid on both.
Does it matter the order between your two statements here?
They do not have to be written in order. You can rearrange the order. I'm seeing a lot of different answers when I walk around. Okay, I'm going to pull us back and let's see. I love the conversations you're having. Okay, so on this first one, when I walked around, I saw both answers on your paper. Some people had valid, some people had invalid. So go back. What's the part they have in common up here? It's even. So cross out the part that they have in common. Then it is even if a number is even. So the part they have in common has to go away. Your new sentence should start with the word if and then end with the part then. So if a number is divisible by 2, then it is an integer. Is that what they said? No, they tried to switch it and say if a number is an integer, then it's divisible by 2. Can we switch and go backwards? No, so this is invalid. Okay, before I go on, questions, because some of you had valid here, and I want to make sure that you understand why it's invalid. Any questions? Okay, next one. Again, I saw both answers when I walked around on this one as well. Some valid, some invalid. What's the part that they have in common? Mammal. An animal is a mammal. So cross it out. If an animal is a mammal, then it is a mammal. This one was tricky because your sentences were not written in order. Sometimes you have to rearrange the order that the sentences are written in. You can't switch the hypothesis and the conclusion, but you can write the second sentence first or the first sentence second if it helps you in your mind. But either way, you're going to cross out what they have in common and start where the word if is. If what? It's okay if it's out of order as far as the way the sentences are written. Yes. So our new sentence should say what? Exactly. Is that what they said? Yes. Okay, so this should be valid. So that one was tricky because they didn't write the sentences in the order as we had all the other ones. But the order will not make a difference as long as you start where the sentence's hypothesis was. Any questions on law of syllogism? Okay, so these last 3 examples are all similar, but they have a different direction. They say draw a conclusion from the given information. So you're not writing valid or invalid, true or false. You're actually writing out a conclusion. They're all using the law of syllogism again, though. So we'll do A together, and then I'll let you guys try the last 2. So it says, given, if 2y equals 4, then z equals -1. So there's our first statement. Second one, if x plus 3 is equal to 12, then 2y is equal to 4. Then they give you some more information. X plus 3 is equal to 12. Okay? So we're supposed to come up with a conclusion. First thing we need to do is figure out what's the part they had in common. Cross it out. 2y equals 4, then 2y equals 4. So what should your new sentence say with the law of syllogism? Okay, so then they tell you x plus 3 does equal 12, so what conclusion can you make? So if x plus 3 equals 12, then z is -1. And they tell you x plus 3 is equal to 12. So then your conclusion is just z equals -1. You are just basically stating the conclusion in the sentence. Does that make sense? Okay, when you get back from lunch, go ahead and try the last 2 examples. For time purposes, just to make sure, because a lot of you are finished, a couple are still working, and that's okay, but follow along with us up here. So just to make sure you're clear, the first thing you want to do with the law of syllogism is mark out the part they have in common. Don't physically mark it out in your textbook, okay? Rewrite it if you need to, or mentally mark it out. So the part they had in common was the angles being supplementary, right? So you mark that out, and now you have your new statement. If the sum of the measures of 2 angles is 180, then they are not angles of a triangle. That's our new if-then statement. Here's the information that they give you extra. A is 135, B is 45. Does that add to equal 180? Yes. So if your two angles sum to 180, then what is the conclusion that you can make? They are not angles of a triangle. And be specific because you're starting with the word they. So a better sentence would be angle A and angle B are not angles of a triangle. Okay? So make sure that you're identifying your subject. Try not to start things with if it, if they, if them, or it, they, and them. What is it, they, and them? Okay? Last one here. So again, they give you two if-then statements. If a polygon is a triangle, then it has three sides. If a polygon has three sides, then it is not a quadrilateral. What's the part they have in common? Three sides. So mark out your three sides parts, or mentally mark it out in your mind. What is our new if-then statement? Okay, if a polygon is a triangle, then it is not a quadrilateral. The next bit of information they give you is polygon P is a triangle. If a polygon is a triangle, so what can we conclude about polygon P? Exactly. So polygon P is not a quadrilateral. And again, if you said it is not a quadrilateral, go back and identify your subject, polygon P, okay? So try not to start it with it, they, them. Any questions about 2, 3? Is it starting to make sense, law of detachment, law of syllogism? All right. The next one is really short, 2, 4. We're just going to have to look at a couple of different examples. But it is really basically just one extra statement, okay? So we had, again, our 4 kinds: conditional, converse, inverse, contrapositive. This is our 5th kind of statement, a biconditional statement. The reason we're going to learn this is because every definition that you learn can be written in the biconditional form. Every definition goes both directions, and that's what a biconditional statement does. So we're learning this 5th type of statement because of our definitions. And then there's 3 definitions that you probably already know in the notes, but just to make sure, we're going to go over those. And that's all there is to section 2.4. So a biconditional statement is not going to be written in the form if P then Q. A biconditional statement, you get rid of the word if, you get rid of the word then, and your biconditional statement is written in the form P if and only if Q. So instead, you have hypothesis, and then you have this little phrase, if and only if, and then your conclusion. You can only write a true biconditional if both the conditional statement and the converse are both true. So if your conditional statement and your converse are both true, then you can write a biconditional. Okay, so for example, I'll use acute. So an acute angle, or let's say it this way, sorry. An angle is acute if and only if it measures between 0 degrees and 90 degrees. Okay? Do you see the phrase if and only if in that statement? Okay, the part before it is the hypothesis, the part after it is the conclusion. It is biconditional if it can go both directions and be true. So do you agree that if an angle is acute, that it measures between 0 and 90? And do you agree that if an angle measures between 0 and 90, then it is acute? So if it's biconditional, that means it can go both directions and it's still true. Whereas before, you couldn't go backwards, right? But if you can go backwards and it's still true, then you can write it as a biconditional statement. You drop off the word if, and you get rid of the word then, and you insert in the middle if and only if. There's all other ways you can write it, but we're just going to do if and only if. So a biconditional statement symbolically, remember how we wrote all of those symbols last class P arrow Q was conditional. Q arrow P was converse. P double arrow Q means that it can go both directions, and that's a biconditional. If it can go both directions, you use double arrows. It means P implies Q and Q implies P. So it works both ways. Okay? The other thing the book is going to do, and I do not want you to do this, okay? But the other thing they're going to do is they're going to do IFF. And it looks like a typo, but it's not really a typo. It's another way of writing if and only if in short form. Okay? But I don't want you to do that. I want you to write it out if and only if. If you see that, though, just know that is the phrase if and only if. Okay? They didn't just accidentally put an extra F. Okay, so first example they give us is they want us to take this biconditional and they want us to separate it into the conditional statement and its converse. So how do you know when you read this statement right here that it is biconditional? So you pick out this little phrase, if and only if. That means the part that comes before it is your hypothesis, and the part that comes after it is your conclusion, right? Okay, so now what they want us to do is to write a conditional statement, which is in the form if, then, and then they want us to write the converse, which is the hypothesis and the conclusion. So let's start with our conditional. What would our conditional say? Perfect. If an angle is obtuse, so Levi just started with the beginning of that sentence, but started with the word if, comma, then its measure is greater than 90 and less than 180. Okay, remind me, converse is going to do what to this again? Switch it, right? Flip the hypothesis and the conclusion. So go ahead and tell me, what would my converse say?
If an angle's measure is greater than 90 degrees and less than 180 degrees, then it is an obtuse angle.
Very good, and I love that you didn't start with if it's. You started with if an angle. You went back and repeated what the subject was. So if an angle's measure is greater than 90 and less than 180 degrees, comma, then it is an obtuse angle. Just remember to not start a sentence with if, it, they, or them. Okay, so go back and identify what the subject was about. So this works both directions, just like the example we put up here with acute. And so they wrote it as a biconditional, but we can then separate it into a conditional and its converse. Any questions there? Okay. I'm not going to do this one because we already did it on the board. This is, again, just conditional and converse, so let's skip that. But do notice they use that IFF. That means if and only if. So we'll skip this one. It's the same thing. Let's go to the next one. This one says, for this conditional, write the converse and the biconditional. So now we're going to have to write the converse and then combine them to write the biconditional. So somebody tell me, what would the converse of this statement say? You got it. Everybody with here? If the points, he identified what he's talking about, are collinear. So instead of saying if they are collinear, he went ahead and defined it. If the points are collinear, then they lie on the same line. And again, these are all definitions, right? Because they go both directions. The definition for collinear are points that lie on the same line. The definition for acute, between 0 and 90. So definitions can always go both directions. Okay, then I want you to write the biconditional. So what's the biconditional going to say?
The points are collinear only if and only if they lie on the same.
Okay, and I will accept your biconditional either direction because it goes both ways. So you could say the points are collinear if and only if they lie on the same line, which would be inserting if and only if in the middle of the converse. Or you could say points lie on the same line if and only if they are collinear. Because again, it can go either direction. So it doesn't matter whether you're putting the if and only if in the converse or the if and only if in the conditional. Does that make sense? So I would accept either answer. So points lie on the same line if and only if they are collinear. If it's a true biconditional, it can go either direction, so it doesn't matter. Okay, just make sure you have that if and only if in the middle. Any questions? Okay. Oops. I already said this. Here it is stated again. For a biconditional statement to be true, both the conditional statement and its converse must be true. If either one of them is false, then the entire biconditional is false because it can't go both directions. So the next thing they're going to ask you to do is determine, is your biconditional true? And then if it's not true, you have to give the counterexample. That goes back to what we learned before. So you're going to decide, can this biconditional, here's this word phrase if and only if, can it go both directions and be true? If it is, you put true. If not, give a counterexample. So a rectangle has side lengths of 12 and 25 if and only if its area is 300. Is the conditional true? If a rectangle has 12 and 25 side lengths, is the area 300? What's 25 times 12? Think about it in terms of quarters. If you have 12 quarters, so it would be 300, right? Because 4 quarters makes a whole dollar, or so then you would have, if you think about it that way, you would have 1, 2, 3, or 300 since this is not 0.25. So 300 centimeters squared. So is the conditional true? Okay, now go backwards. If you have a rectangle that is 300 centimeters squared, does it have to have side lengths of 12 and 25? No, give me a counterexample. 30 and 10, okay? So 30 centimeters, 10 centimeters. Remember, a counterexample can be a picture, it can be a statement, or it can be numbers. So you could just draw a picture of a rectangle with different dimensions that still give you an area of 300. So the answer to this would be false, and this is our counterexample. Does that make sense how you're checking it both directions? Okay. Sorry, did I go too fast? Does anybody still need that? Okay.
So I have a question. For that one, could we write as like the counterexample?
The picture that I drew would be your counterexample, where you labeled the sides 30 and 10. So that shows that the area is still 300, but the side lengths were not 12 and 25. Okay, what about this one? True or false? It's true, right? An angle is a right angle. If an angle is a right angle, its measure is 90. If an angle's measure is 90, it is a right angle. This is the definition. Every definition is biconditional, so this would be true. Okay, what about this one? This is written symbolically with the arrows. True or false? Okay, so if y is negative 5, if I plug in negative 5 and square it, do I get positive 25? Okay, go backwards. If y squared is equal to 25, does y have to be negative 5? No. So you are right. This is false because when we look at the converse and switch it, what are my possibilities for y? 5 or negative 5. So if I'm solving this equation, I can get 2 answers. But if I'm just given y is negative 5, then y squared would be 25. So false, and my counterexample would just be y could equal 5. Remember, your counterexample is a specific number picture statement. Easy? Okay, we're almost done, and you're going to get time to work on your homework today. The last thing in the notes are just some definitions, okay? And again, one of them I want to be really specific about. The other 2 you should already know. The first thing, though, is definition of definition. So a definition for our class is a statement that describes a mathematical object. But a definition could describe any object, right, in every class. But for our class, our definitions are going to be statements that describe mathematical objects. And I've said this at least 2 or 3 times already. Every definition can be written as a true biconditional. Okay? Every definition. And the reason I want to keep saying that, just a heads up, when we get to proofs on Friday, and you're trying to decide, what can I use in my proof? Keep in mind, if they tell you it's a right angle, you automatically know that it measures 90 degrees. If they tell you that it measures 90 degrees, that means you know it's a right angle. So they go both directions, and that's what's going to be important for proofs. Okay, this is the only one I want to focus on. The other 2 you should know, so we'll look at those in just a second. Polygon is going to come back later in a couple chapters, and it's important you understand what a polygon is and what it is not. So first of all, a polygon has to be closed. So notice this is not closed, so therefore it's not a polygon. The other thing is it has to be a plane figure, and by plane figure we mean 2-dimensional. So notice this one is not 2-dimensional, it's 3-dimensional. It's not a polygon. Polygons have to be formed by 3 or more line segments. So again, this is made up of curves, therefore it's not a polygon because it's not made up of segments. The last thing, though, that's not here that I would add to your notes if I were you is, and they must intersect at the endpoints. So they have to be made up of line segments, but those line segments must intersect at the endpoints. So notice this example under not polygons, it doesn't intersect at the endpoint, right? And the same thing here, this is really 2 polygons put together, but if you think about this as a line segment, it's intersecting this other line segment in the middle. So they would say that's not a polygon. Okay, it's 2 polygons put together. Any questions about polygon? All right, and again, I would hope that you came to this class knowing that a triangle has 3 sides and a quadrilateral has 4 sides, right? All right, any questions? Okay, then I'm not going to worry about the last examples. We've already talked enough about biconditional. I think you're probably good. So homework, you have a good 30 minutes today. Use that to your advantage. You may listen to music, but don't get distracted by your phone. Try to get as much done as you can.